Welcome to chemistry classes. In this video, we are going to discuss about alcohol, phenol and ether. Here we have to discuss here chemical reactions of alcohol. Chemical reactions of alcohol which involve carbon-oxygen bond breaking. Bond cleavage of carbon-oxygen bond. Okay, we know alcohol functional group OH directly attached to carbon atom. Previous video we discussed chemical reactions of alcohol which involved oxygen hydrogen bond breaking. Now we have to discuss here chemical reactions of alcohol which involve carbon oxygen bond cleavage or carbon oxygen bond breaking. Okay, here first we have to understand phenol. We know phenol, it is aromatic alcohol. Phenol showing this type of chemical reaction only in presence of zinc. Okay, zinc dust or zinc powder. Phenol showing this type of carbon oxygen bond cleavage only in presence of zinc dust. Clear? Here chemical reactions of alcohol which involve carbon oxygen bond cleavage. First chemical reaction we have to discuss here chemical reaction with hydrogen halide. HX. X represent here halogens, chlorine, bromine, iodine. Okay, here alcohol reacted with hydrogen halide. Alcohol will change to alkyl halide. Alcohol reacted with hydrogen halide, this bond will break, then halogen will directly attach to alkyl group. Alcohol will change to alkyl halide and water will be side product. Example for this type of chemical reaction, alcohol reacted with HCl, it will change to alkyl chloride plus water. This chemical reaction takes place in presence of zinc chloride and HCl. This chemical reaction called Lucas test. Lucas reaction or Lucas test. Okay, so Lucas reagent mean HCl in presence of zinc chloride. This reagent called Lucas reagent. Okay, this Lucas test helps to distinguish primary, secondary, tertiary alcohol. We know there are three different type of alcohol: primary alcohol, secondary alcohol, tertiary alcohol. We can distinguish primary, secondary, tertiary alcohol with the help of Lucas reagent. Lucas reagent means zinc chloride in presence of mixture of zinc chloride and hydrochloric acid, that is Lucas reagent. So here we discuss Lucas test helps to understand primary, secondary, tertiary alcohol. Here we have to understand tertiary alcohol. Before that you have to understand alcohol will be soluble in Lucas reagent. Alcohol and Lucas reagent miscible, soluble. Okay, but here we know alcohol reacted with HCl, it will change to alkyl halide, alkyl chloride. So alkyl chloride or alkyl halide, it is immiscible in Lucas reagent and it produces a turbidity. It produces a turbidity in Lucas reagent. Okay, so basically you understand alcohol dissolved in Lucas reagent, alcohol miscible in Lucas reagent. But alkyl halide, after alcohol reacted with HCl, it will change to alkyl chloride or alkyl halide. It is immiscible in Lucas reagent. It produces a turbidity in Lucas reagent. Okay, so here formation of turbidity, it is the observation. Lucas reagent reacted with alcohol, then there will be a turbidity. So the formation of turbidity helps to understand completion of chemical reaction. Okay, so tertiary alcohol reacted with Lucas reagent, a turbidity formed immediately. Turbidity formed immediately with tertiary alcohol. So you have one alcohol, okay, it is unknown alcohol. We don't know it is primary, secondary or tertiary alcohol. Given alcohol reacted with Lucas reagent, a turbidity formed immediately. It indicates given alcohol is tertiary alcohol. Okay. Similarly here primary alcohol forms turbidity with Lucas reagent after heating, after some time, not forming immediately. Okay. So here given alcohol forming turbidity after heating after some time, so it indicates the given alcohol is primary alcohol. So reactivity of alcohol with the Lucas reagent we can arrange. Tertiary alcohol is highly reactive than secondary than primary. So this is the order of reactivity of different alcohol with the Lucas reagent. Clear? So this is Lucas test. Lucas test helps to distinguish primary, secondary, tertiary alcohol. Okay. Lucas reagent means zinc chloride in HCl. Okay. Here after this chemical reaction, now we discuss chemical reactions of alcohol with hydrogen halide. Next one, chemical reactions of alcohol with phosphorus trihalide. X again halogen, PX3, phosphorus trihalide. Example here PCl3. Okay, PCl3. Alcohol reacted with the PCl3. Here alkyl halide. Again alkyl halide will be formed, and here side product will be H3PO4. Sorry, H3PO3, phosphorus acid. Okay, H3PO3. Here three alcohol molecule reacted with the PCl3. 3 alkyl chloride will be formed. Okay, so here 3 hydrogen here, 3 oxygen here, 1 phosphorus here. They combine to form H3PO3, phosphorus acid. Okay, so this is chemical reactions of alcohol with the phosphorus trihalide and Lucas test or Lucas reaction. Okay, next one, third chemical reaction we have to discuss here, dehydration. Dehydration means removal of water. Hydration means addition of water. Dehydration means removal of water. After dehydration, alcohol will change to alkene. Okay, after dehydration, the product of alcohol after dehydration, product will be alkene. Concentrated sulfuric acid used for dehydration. Dehydration takes place in presence of concentrated sulfuric acid. Here concentrated sulfuric acid used as dehydrating agent. To remove water we will use concentrated sulfuric acid. Also same dehydration takes place in presence of zinc chloride and alumina. Anhydrous zinc chloride or anhydrous alumina used as catalyst for dehydration. So here we are talking here third chemical reactions of alcohol. Alcohol after dehydration it changes to alkene. Alcohol after dehydration, alkene will be the product. Here chemical reaction, this chemical reaction takes place in presence of concentrated sulfuric acid. Concentrated sulfuric acid is dehydrating agent, and here catalyst used zinc chloride, anhydrous zinc chloride or anhydrous alumina used as catalyst. Okay, and here example for such type of chemical reaction, this is ethanol, C2H5OH, ethanol. After dehydration, ethene will be the product, water removed, ethene. Propene, this is propan2ol, propanol, or you can say propan2ol because OH in second carbon. After propan2ol after dehydration, propene will be the product, propene. Okay, propanol after dehydration, propene. ethanol after dehydration, ethene, butanol after dehydration, butanol. So here this is primary alcohol and this is secondary alcohol. Okay, here OH attached carbon directly attached to carbon atom. So here primary alcohol after dehydration, alkene, secondary alcohol after dehydration, alkene. Also tertiary alcohol, here this is tertiary alcohol, OH attached carbon directly attached 3 different carbon atom. This is tertiary alcohol. Tertiary alcohol after dehydration, corresponding alkene will be formed. So you can check here primary alcohol C2H5OH or CH3CH2OH, it is primary alcohol. Dehydration takes place at 443 Kelvin and concentrated sulfuric acid. Secondary alcohol after secondary alcohol dehydration takes place 440 Kelvin and here 85% phosphorus acid needed. Here concentrated sulfuric acid needed. For primary alcohol, concentrated sulfuric acid. Secondary alcohol, 85% of H3PO3 needed. For tertiary alcohol, 20% H3PO3 needed. Okay, so here for primary alcohol, concentrated sulfuric acid needed. For secondary alcohol, 80% H3PO3 needed. For tertiary alcohol, 30% H3PO3 needed. We know concentrated sulfuric acid is more stronger. So dehydration of primary alcohol is difficult. It needs more concentrated sulfuric acid. Secondary alcohol is comparatively easy to dehydrate. It needs 80% H3PO3. Okay, comparatively tertiary alcohol is easy to dehydrate. It need only 20%, not 30, 20% H3PO3 needed. So this is the order of dehydration of alcohol. Here primary alcohol is very hard to dehydrate, okay, and it need concentrated sulfuric acid and 443 Kelvin temperature. And here tertiary alcohol easy to dehydrate comparatively. It need 20% H3PO3 and 358 Kelvin. Clear? So here we discuss dehydration. Dehydration takes place in presence of concentrated sulfuric acid or H3PO3, phosphorus acid, and here catalyst anhydrous zinc chloride or anhydrous alumina used as catalyst. Okay, and here this is the order of dehydration. Okay, tertiary alcohol is easy to dehydrate, then secondary, then primary. Okay, so here we discussed dehydration. We discussed dehydration of alcohol. After dehydration of alcohol, alkene will be the product. This chemical reaction takes place in presence of protic acid. Protic acid means acid, it provides proton H plus, H2SO4, H3PO3. These are protic acid. Okay, and the alkene will be the final product of this dehydration. Clear? So here this is example for this is the mechanism for dehydration. This is the mechanism for dehydration. There are 3 different steps for dehydration. Okay, so here in first step, in step 1, formation of protonated alcohol. Okay, formation of protonated alcohol. We know alcohol means CH3CH2OH. This is alcohol. In oxygen there is 2 lone pair electron. Okay, this proton will be attract on this oxygen atom, and this proton is coming from protic acid. Protic acid means H2SO4 or H3PO3 provide this proton. This proton combined with this oxygen form CH3CH2OH2. Okay, this is not final product. I told you this is mechanism for this chemical reaction, CH3CH2OH2. This CH3CH2OH2, this is this is protonated alcohol. This is protonated alcohol. Or you can say here 2 carbon atom. Okay, 2 carbon atom. So you can say ethyl oxonium ion. Oxonium ion. This part called oxonium ion. Here 2 carbon. So ethyl oxonium ion. If there are 3 carbon, propyl oxonium ion. Okay. So in first carbon, this is protonated alcohol is formed. Okay, second step, formation of carbocation. Okay, this protonated alcohol, this is protonated alcohol, same CH3 CH2OH2, same thing here, CH3 CH2OH2. Okay, so here in slow step or in this chemical step, here this H plus will be removed. Okay, and look here, in this step this part completely removed. Okay, this part completely removed as water. H2O will be removed, and here CH3CH2. We know CH3CH2 means this is carbocation. This is carbocation. Okay, so here in second step, formation of carbocation. Here protonated alcohol, water will be removed. Water will be removed minus H2O. After removing water, carbocation will be formed. Okay, here third step. In third step, look here CH3 CH2 plus. Here CH3. One of this hydrogen release as H plus, and rest of the part change to CH2 double bond CH2. So here ethene is formed. So here we started from ethanol. This ethanol finally changed to ethene, and this chemical reaction takes place in presence of concentrated sulfuric acid or phosphoric acid. So this is phosphoric acid or sulfuric acid. Okay, this H plus provide from protic acid, and this act as a catalyst. Okay, in the beginning there is H plus, at the end also there is H plus. So H plus not consumed during chemical reaction. So here there are 3 steps for dehydration of alcohol. First step, protonated alcohol formed. Second step, after removing water, carbocation is formed. Third step, after rearranging this bond, or after releasing one H plus, this carbocation changes to alkene. Clear? So this is the 3 different steps in the mechanism of dehydration of alcohol. Clear? Okay, next one we have to discuss here oxidation of alcohol. Next one we have to discuss here oxidation of alcohol. Primary alcohol, after oxidation it will be aldehyde. Primary alcohol, after oxidation it will be aldehyde. Aldehyde, further oxidation it will be carboxylic acid. COOH, carboxylic acid. Okay, we know alcohol, it contains carbon, oxygen, hydrogen, single bond. After oxidation, here carbon double bond oxygen bond will be formed. Carbon double bond oxygen, CO bond. This bond commonly called carbonyl bond. Carbonyl bond means the compound which contain carbon double bond oxygen. Okay, so generally alcohol after oxidation, aldehyde or carboxylic acid will be formed. Okay, aldehyde, ketone, carboxylic acid, this type of compounds formed. All these compounds which contain carbon double bond oxygen. So imagine this is one alcohol. Okay, here alcohol CH3OH, methanol. So here carbon hydrogen single bond, oxygen hydrogen single bond, this bond will be break, and a new bond formed between carbon and oxygen, and carbon oxygen single bond changed to carbon double bond oxygen. So during oxidation H2 will be removed. Okay, so oxidation means during oxidation dehydrogenation takes place. 2 hydrogen atom removed. Removal of hydrogen atom, dehydrogenation. Hydrogen will be removed from alcohol. Okay, and new bond formed between carbon and oxygen, a double bond formed, okay, and carbonyl bond formed. Also remember here primary alcohol after oxidation aldehyde. Aldehyde further oxidation it will be carboxylic acid. Okay, for oxidation we will use oxidizing agent. We will use oxidizing agent potassium dichromate. Acidified potassium dichromate used for oxidation. Okay, acidified potassium dichromate. Acidified potassium dichromate K2Cr2O7 potassium dichromate or acidified potassium permanganate. Acidified potassium permanganate or acidified potassium dichromate used as oxidizing agent. Potassium dichromate, it is orange color. After oxidation it will change to green. Okay, so after using potassium dichromate, observation, orange color turns to green. Okay, before oxidation orange color, after oxidation green. Acidified potassium permanganate used as oxidizing agent. Acidified potassium permanganate purple color, after oxidation it will be colorless. Okay, purple color turns to colorless. Before oxidation purple color, after oxidation colorless. Clear? So here this is one example, ethanol after oxidation, ethanol, aldehyde, ethanol. Okay, ethanol further oxidation, ethanoic acid. Ethanol, this is primary alcohol, aldehyde, carboxylic acid. Ethanol, ethanol, ethanoic acid. Okay, but here this is alcohol. We can convert alcohol to carboxylic acid. Here first primary alcohol turns to aldehyde, aldehyde then turns to carboxylic acid. We can change primary alcohol to carboxylic acid directly after oxidation, after using strong oxidizing agent. After using strong oxidizing agent, primary alcohol can turn to carboxylic acid directly. Okay, this process happening in presence of weak oxidizing agent. In presence of strong oxidizing agent, we can change primary alcohol to carboxylic acid directly. Okay, here strong oxidizing agent, example acidified KMnO4. Okay, after using acidified KMnO4, acidified potassium permanganate, primary alcohol directly turns to carboxylic acid. Clear? Also look here, anhydrous chromic oxide, anhydrous chromium oxide. After using anhydrous chromium oxide, we can turn primary alcohol to aldehyde. Okay, after using chromic oxide or after using anhydrous chromium oxide, we can turn primary alcohol to aldehyde. This is another oxidizing agent, anhydrous chromium oxide or chromic oxide. Okay, so here primary alcohol to aldehyde. You want to turn primary alcohol to carboxylic acid directly, use acidified potassium permanganate. Also another oxidizing agent, PCC. PCC means pyridinium chlorochromate. Pyridinium chlorochromate, PCC. Okay, this is another oxidizing agent. After using this, we will get good yield of aldehyde. Okay, here when we use chromium oxide, we will not get good yield. Here yield of aldehyde will be poor yield. We want to get high yield of aldehyde, then we have to use PCC to oxidize primary alcohol. So we will get good yield of aldehyde. So which oxidizing agent used to get high yield of aldehyde? PCC, pyridinium chlorochromate. Okay, so look here one example. This compound which contain carbon CH3 CH double bond CH CH2OH. So this compound contains two functional group, carbon-carbon double bond and OH. After oxidation using PCC, here alcohol, primary alcohol, this part changed to aldehyde. There is no change for alkene part no change, only primary alcohol part change to aldehyde, okay, in presence of PCC. Clear? Also here secondary alcohol after oxidation using chromium oxide, it will change to ketone. Clear? Secondary alcohol after oxidation ketone, here we used anhydrous chromium oxide, okay, or we can say chromic anhydride. This is chromium oxide, we can say chromium oxide or anhydrous chromium oxide, chromic acid, chromic anhydride, chromium oxide, all things same. Chromium oxide, chromium trioxide, chromic anhydride, chromic acid, okay, all the things same, CrO3, okay. Okay, so here we discuss primary alcohol after oxidation aldehyde, secondary alcohol after oxidation ketone, tertiary alcohol there is no chemical reaction. Tertiary alcohol cannot oxidize, there is no reaction after oxidation. Okay, also we have to understand here, under strong condition, under strong oxidizing agent and a very high temperature, carbon-carbon bond breaking takes place. In alcohol here CH3CH2OH, okay, this is CH3CH2CH2OH, it is propanol, and the strong oxidizing agent such as acidified potassium permanganate, and very high temperature, this carbon, okay, any one of this carbon-carbon bond will be break and a mixture of carboxylic acid formed. Here example here, this is propanol, okay, propanol under strong condition, strong oxidizing agent and very high temperature, this carbon-carbon bond breaking takes place and a mixture of carboxylic acid, okay, here methanoic acid and ethanoic acid formed. Okay, so here remember at very high temperature and strong oxidizing agent, here oxidation takes place and a mixture of carboxylic acid formed. Here bond breaking takes place between carbon-carbon single bond. Clear? Also we have to understand here another thing, after passing vapors of primary, secondary, tertiary alcohol through copper powder at very high temperature, different type of chemical reaction takes place. Vapors of primary, secondary, tertiary alcohols are passed through copper powder at very high temperature, 573 Kelvin. Okay, so here different type of chemical reaction takes place. Here primary alcohol changes to aldehyde. Okay, primary alcohol changes to aldehyde. Secondary alcohol changes to ketone. Secondary alcohol changes to ketone, and tertiary alcohol changes to alkene. Okay, so this test also helps to understand, also helps to distinguish primary, secondary, tertiary alcohol. Clear? So here vapors of primary, okay, here not alcohol, not liquid state, here we have to use vapors of primary, secondary, tertiary alcohol. You have one unknown alcohol, you want to find it is primary or secondary or tertiary. So given alcohol convert into vapor, this vapor pass through copper powder at very high temperature. Okay, depends on your product, you can identify given alcohol. If it is primary alcohol, if it is aldehyde, the product obtained aldehyde, so it is primary alcohol. The product obtained ketone, so it is secondary alcohol. The product obtained alkene, then it is tertiary alcohol. So depends on the nature of product obtained, we can identify the given product. Clear? So these are the different chemical reactions we have to discuss in this video. Clear? So here we discuss different type of alcohol and their chemical reactions. Okay, we discussed alcohol and a different chemical reaction, and we have to discuss phenol and their chemical reaction. So we will discuss chemical reactions of phenol in next video. So thank you for watching this channel.